So, cyber physical identities, who's the godfather of the digital twin? In the program I put in, who's the stepfather? It was a mistake by me, but maybe stepfather is also not really wrong. Okay, of course, in Germany, if we talk about cyber physical system, we have this industry 4.0, and I think this picture and this meaning is widely accepted. Of course, you have some specific marks or criteria to define industry 4.0. Sorry, I have just to start to improve my English. And one of the most important is the connecting between the physical and the digital world, of course. We can call it cyber physical systems. CPS, of course, normally we understand, of course, that certification practice statement, but in this meaning here is a cyber physical system. And this is quasi an important topic. You really try to keep the real world connected to the virtual world. And this is, of course, we are talking about PKI, a very important task for PKI. But of course, this combination of different systems is not only vertical, that means between company departments, it's also horizontal. That means you have to connect different partners beyond the fence of your company, of course. Then we have intelligent machines. Now we would call it maybe artificial intelligence, or former times we called it rule-based mechanisms. So we have really an independent information exchange between these different machines, or for example, car to car. Of course, we are talking about now that a car authenticates against a parking lot or a parking house. Since we have exactly no idea how we should operate it now, but of course it will happen within the next 2 or 3 years that we have a fully automatically operated parking lots or parking houses. So even my car is able to find a parking lot by its own and park in. I doesn't trust it very much, but it's able to do so. But my children, of course, wouldn't think about. But of course, it's all about identity and authentication. If these virtual identities have transaction with each other. And another, of course, important topic in this type of smart factory, you have to clearly identify and localize products. You have to know where it is. Is it in China? Is it in Taiwan? Or is it at the Siemens site in Berlin or Munich? That's an important topic. And of course, in the physical world, no doubt about it. You can see it, you can feel it, you can move it. But of course, in the virtual world, it's really an issue. And of course, the last point in Industry 4.0, it's controlling and optimization in real time. Of course, we don't do it batch. Everything is connected online, working very fast together, making interaction, and it's connected real time. So an example for one smaller part of this Industry 4.0 is a digital twin. So here we have a very expensive facility, of course, a platform for exploring oil. Maybe it's 300 million euros or 400 million euros, and the ship. And of course, companies also located in the Scandinavian area, experts in, and they have really perfect digital twins. Because this facility is so expensive, so they can really operate and manage a team of people who deal with these digital twins, from the platform and the ships providing services. So there's a one-to-one between the real world and the physical world. So what is the definition of a digital twin, of course? You have a comprehensive replica and a representation of physical objects in your computer. Of course, you have advanced analytics, and what's, of course, quite important and getting faster now, machine learning. Of course, it gets more sophisticated, more and more. But of course, if something goes wrong with machine learning, of course, it also accelerates to go in the wrong direction very fast. Then we have static and historical and real-time data. It's mixed in between. And so you have really also to use techniques to improve if it's a trustworthy data from the historic, or is it maybe some fake. And here is it again, you have to matching cyber and physical identities in the life cycle over 10 years. In the morning we had before the example of the life cycle of a car. And of course here, if you have this digital twins, you have the same problem or the same challenge, of course. And the idea from the digital twins, personally, motivated me very much. I was 4 years ago or 5 years ago, I visited the Rolls-Royce production site near Berlin. They produce all the fans and engines for the Airbus 319, 320. And of course, they have really a perfect digital twin implemented, because they have around 50 to 20,000 engines outside, and each of this engine has a digital twin in a database, and of course they know what happens 5 years ago, 3 years ago, and who was the owner before and who will be the owner later. So they guide this Rolls-Royce aerospace engines, they guide a complete system to control the system over the whole life cycle. That's the best case of the digital twin, but it's in one domain, of course. And we're talking about PKI infrastructure, hopefully cross-domain. So here is the other slide. It's from Siemens. I haven't seen Rufus here before, and it's a very good. Sorry. Okay. And of course, it's a very good message that also now deal with this local registration. Yeah, okay, I have to learn about it. I heard it the first time in the morning about it. But of course, it's an important issue. Here in cyber physical system, of course, you deal not only with the digital product and the development, you have the production and the digital performance over the life cycle. Okay, that's the idea beyond, but now let's see how to implement it. And if you take a look to this type of market, normally we act with norms and standards and things like that, but if you take a closer look, there are just a few international standards relevant for combining cyber physical systems or combining digital identities and real identities. Of course, there's an ISO standard that is quite well developed. It's of course working with PKI. That's not surprising very much. And you can combine it with a label, with an RFID tag, or just with a number. That's a possibility to use this standard. But that's quite poor from the complete infrastructure. So if you want to implement digital twins, you have these mandatory requirements, of course. You have to have a proper matching of cyber and physical identities. And of course, you have a very good protection against denial of service and of course manipulated code. And I think in the morning we had the wording about code signing 5 or 6 times, much more than the last year. So I think code signing get more important. Here it's also very essential. And of course, PKI is the enabling technology to use this interesting technique or concept of digital twins. But we have to define a common data structure and a global or maybe European or maybe international PKI infrastructure to exchange this type of information. Now, these first concepts are locked in, of course, and Rolls-Royce will take care a lot about to protect their data, and Boeing won't exchange it with Airbus. Of course, this PKI infrastructures are still in silos, but to put it into practices, of course, we have the requirement to have it as an infrastructure on global scale. So, of course, in the engineering, you should have a product lifecycle management supported across the whole value chain. Then, of course, it's very important that you have also the vertical integration. That means the network of the production should be connected and also work real time. Then we have the horizontal integration, so between the different companies, and of course the technology requirement. And of course there is one, of course, cybersecurity, but to be honest, the most engineers are working in the industrial field. They don't take care about security very much. They just think about, okay, here's my production plant, here's the fence, and maybe have some guards that protect the plants, and that's still this thinking in these silos. But of course, in the virtual world, you have many other demands to combine these systems. And maybe you can see here the IDAS logos. Okay, the IDAS logo. Of course, this physical system, of course, have to have a defined identity, and of course, the cyber machine has to have an identity or a seal to protect this type of infrastructure. So the question of the lecture was, okay, who's a godfather? Who is somebody who is able to put these things together? And of course, we have some names. We talked about Cisco is active in that field, Amazon is active in this field, but I think it's more about consumer IoT, not so much about high-value good and complex infrastructures. So there is no clear answer, and so I want to move to another presentation we prepared, because at Etsy, we also mentioned Etsy, of course, we made a study about the globalization on trust. And this study is about different trust schemes we have already implemented, and of course about this discussion about European audits, web trust audits, and other audits. Of course, we want to take a closer look at this IDAS concept with these different products. How does it fit into other frameworks? So it's really a study, very systematical, to get a big picture about existing operating infrastructure for trust services. And of course, we have these different products within IDAS defined. You already mentioned the qualified website certificates, very specific, but on the other side we have the seals, the timestamps, and of course registered electronic delivery service. Just to mention, the qualified seal is also mandated by law that you can use it for code signing. Maybe if you think about code signing, you can just use also definition for electronic seals with the identity of companies. It's maybe an alternative approach to the code signing within Microsoft Authenticator, things like that. So that's a complete environment. So in this study, we tried to get a big picture, and we have been in the lucky situation to make different workshops, of course, not only to present our solutions, of course, to get a big picture. So we went to Dubai, and I was really impressed about Oman and also the implementations in the Emirates. Of course, most of them based on PrimeKey. I don't get paid for it, sorry. Of course, then we went to Tokyo, and of course, Tokyo is very much aware about identities coming from Japan or from Tokyo. Of course, they are very much aware, protect their infrastructure, their cyber physical systems against fake or maybe parts that are in the same quality but with a lower price. So they protect also their cyber physical systems, and they are very much keen on getting more detailed information from Europe. Then there was a presentation or a workshop in Mexico, of course, and in South America. There is more PKI deployed than we expected, but of course they don't talk so much about for any reason. But of course, maybe they have sometimes some other problems. North America, in New York, of course, that was just a few days ago. To be open, it was still quite difficult to come into good discussion with our American colleagues. But that's it if we now cooperate between Europe and the United States. But I don't want to talk about the political issue. So if to get the big picture, how to combine electronic identities and trust services, we have defined different pillars. So of course we have a legal context on the left side, of course. We have to have supervision and auditing. We have to have best practice, how to implement it, of course. And we have to have a trust representation. And I think trust representation is something that is forgotten very often, because we have to make trust visible, or we have to have something like a root of trust that is implemented in a proper way so you can work with it. So trust representation is really a tricky thing. And now with CAP Forum, Dimitris will tell tomorrow morning about it. Of course, the green bar in the browser now is no longer supported by Google. So of course, the trust representation is really an issue. So these are the 4 different categories we made our study, and we tried to compare within the study, of course, this, we can call it pyramid of trust. On top, we have the OISAFE logo to make trust visible. It's a trust mark, and every qualified trust service provider is allowed to use it. And of course, we have this trusted list to combine these different systems. So we have heterogeneous CAs all over Europe, and with a trust service list, we can combine it. We have a supervision system, of course, with audits, termination, initiations, ad hoc audits. So there are really always certified audit bodies who can do the supervision under a specific theme and guarantee the quality of the processes, of course. Then, of course, we have the trust service providers, and then, of course, the base are the best practice standards and, of course, signature blocks. And this is a European system, and we try to compare it with other systems, especially if there's an equivalence between the systems. Equivalence in legal context, in supervision, auditing, best practice, and the trust representations. And if we start to take a look, some of the first pictures, the study is not published now, but of course we have here an example, a comparison between the IDAS system on the left side and the web trust system on the other side. And of course, if you want to get publicly trusted, you can do it either via a web trust audit or an ETSI audit based on European accreditation. And so we studied the matching between the different schemes. On the right side, we have web trust licensed practitioner. Of course, that's something that's more motivated by the financial sectors. So a little bit more tax accountants than engineers doing the audits. It's another way to operate, of course. And on the left side, of course, we have the auditors working on IDAS regulation, a more complex environment, of course, and the accreditation scheme. So all the auditors have to be involved in the European accreditation system. Then, of course, we compared it with other parts. We looked to recommendation also from ISO, from NIST, and we try to do a mapping of these different things. For example, we have seen there are different ways. We use the trust list, and I think it's still the state of the art. ETSI is promoting it since 2001. And of course, now the trust list concept will also deploy it in Japan. There was a clear commitment to do it in that way. We have it in the German healthcare sector, and we still try to motivate others for trust service list. For example, also Adobe is using the AATL, that's a specific flavor of trust service status list. But of course, we have still cross-certification. For example, in the New York workshop, we have representatives from the Federal Bridge CA in the United States or from Safe Biopharma or other projects to compare it. And of course, we have this hierarchical approach about trust stores and the pain to get into and the pain if you're no longer in. And of course, with the experience, the trust stores regulated and mandated by Microsoft, Google, Mozilla, and some others, that's really an issue for us. Okay, but this is also described in the study. Then we try to map the different things, and yeah, I think it's a very good principle to map these different schemas and to get a better overview about what's happening in the world. Okay, here are some first results of the study, and sorry, it's a lot of text, because it's a study. It's not still in the state that we promote the results very much, but of course, it's really a different approach if it's a state-owned regulatory scheme, as we normally do in Europe and also in Japan or in China or other parts, or if it's a scheme that is founded by its own, like in the United States, or we can say in countries where case law is, of course. So there's really a difference also with this type of infrastructures from the different law systems. If it's Roman law, or then of course we have another regulation framework if it's a case law in UK, Australia, or other part of United Kingdom. Of course, that's an important point. Then we have seen, okay, there are different facilitators, and we have been quite optimistic that there will be a global approach, for example, by UN Central. So I also work in this forum, but it goes very, very slowly. If you want to get an UN organization understanding PKI and understanding identification, authentication, and signature, it was a hard task with IDAS. I think we started 2012 and finished as 2016 in UN Central to get a global understanding of these mechanisms. It will be 2025 or something like that if this is completely on global scale. But it would be great if we could manage it and would do it. Then, of course, we have something about supervision. That's very difficult, and we have this picture in Europe, of course. We have an accreditation for the audit bodies, and they have to fulfill mandatory standards, European norms, and yeah, but this accreditation doesn't work very properly. Of course, we have different approaches between Austria and Germany, for example. So some audits are much easier to do in Austria than in Germany. That doesn't mean that Austria is doing PKI very unsecure. But of course, different criteria, different regulation approach, but the same law has different results. That's really a problem. Then, of course, we have from the best practice, that's, I think, I made a presentation 5 years ago at the CA Day about many CP spoil the broth or something like that. So we have so many different criteria and catalogs that's really a problem. Of course, also we have a lot of ETSI standard, but we have also CEN norm and of course CAP forum. And now we have the new X509 version, very interesting, also with policy aspect. We have the ISO 27099. So ISO is also starting again after 10 years to produce a new certification policy, 27099. Yeah, okay, read it by your own. And of course, still in my understanding, the most important problem is the trust representation, how to show it to the end user, or maybe how to ensure that the device is able to decide trustworthy or not, or code signed or not. That's really still quite difficult. We have in Europe this concept of qualified, and qualified has a special meaning. Qualified means this is a legal effect. Qualified means it's a specific type of service, and qualified means, of course, also a defined security level. But if it's possible to transfer this qualified something to the rest of the world, it's doubtable in my understanding. And of course, even in Europe, we have sometimes difficult understanding. So we can discuss for the whole day about qualified certificate with advanced signatures using secure signature creation devices. Just to combine these three types of elements is, from the technical understanding, not the same if you talk to a lawyer and you have a legal understanding. Of course, he perfectly knows what qualified means as a lawyer. But of course, as already Thomas said, okay, so we have a lot of QC statements with different meanings. That's very, very difficult to match. Okay, the study, of course, will finish end of 2019, and we will publish it after then. And so we can distribute it, and if you want, we can have a more detailed presentation next year. ETSI always publish all public documents for free, so ETSI norms are always for free, and I expect to have the version there in December or January. Okay, this was about the study. Of course, yes, I'm skipping a little bit around, but I want just to mention this slide. I like it very much, and of course, we have a lot of PKI operators here, and IDAS is not only about qualified, sondern every public trust service provider should mandatorily fulfill the requirements, and a national supervisory body in Europe, of course, can also enforce this. So you have to take, it's all about IDAS Regulation Chapter 1, Section 3. It's about data processing and protection. You are obliged to have a concept for it. You have something like a liability by law, and you have the burden of proof. You have to take care about people with disabilities, and to have to use different interfaces to support them. The supervision body can give you penalties if you don't do it, and there are defined security requirements. And as you already told with the IDAS, we have a table where, oh yeah, sorry, I skipped a little bit too much. There's an ETSI policy, the 319-401, how to implement these basic requirements from IDAS. And there is a matching table we made 1 year ago, how the solution from PrimeKey fits into this set of requirements. Of course, you will get all the slides if you want to see it more detailed. Even with glasses, I'm not able to see it. Okay. And yeah, and one slide more, of course. We had the topic about PST2 certificates. And the PST2 certificates are not for publicly trusted. You can have them publicly trusted if you are able to deal with CAP Forum and Google, and maybe Mozilla. But of course, the qualified website certificates are not website access certificates. They are server certificates for identification and confidentiality. They are not for publicly trusted users in web browsers. That's not the idea when they made this regulation. So that's a misunderstanding. Of course, it's possible to have qualified website certificates that is also an EV certificate with a green bar. That's possible. But now, a few customers of mine are selling a lot of quacks that are not publicly trusted without any problems. Okay, that's just that slide. Okay, thank you very much. That was a little bit through cyber physical systems, digital twins, systems deployed in the whole world. And I hope maybe in more discussion we can get more points on it. Thank you very much.